I want to do a recap. So you've done chapter 5, which is to do with algebraic expressions, meaning just understanding how to use letters. Chapter 7 is different. Chapter 7 is the application. It's actually now to solve problems, and you're going to get a whole variety of different problems, and you have to get comfortable with working ways to unwrap the problem. Last lesson, Ms. Yu tried to teach you this idea of inner vest and then outer vest, right? The idea of order. That was the order that was trying to be taught. So I'm going to recap 2 key examples and really 1 key skill that I want you to practice. Okay, there are 2 methods to do it. 1 entry, and then 1 is an entry, then advanced. But I want you to learn one of the methods. Doesn't matter what for this chapter 7. Okay, so copy this down. Let's do a recap. Let's do a logical thinking. Yeah? Look at this statement. Now, this is a very powerful statement. Even though it looks very simple, but funny enough, all the way up to year 12, there's still errors. And I showed it to my other class that I did just on Monday, and already an error came up. Okay, so it's a very simple idea, but very common to make a mistake. Let's have a look. This statement, when I say 3 equals 3, I'm saying whatever is on this side is equivalent to the other side. Sounds straightforward, true? So let's do a scenario that makes sense. Mr. Tran has $3. Let's say a student, let's pick Nick. Nicholas has $3. Do we have the same amount? Yes. So it makes sense. So Mr. Tran has $3, Nick has $3, we have the same amount. Great. Statement is true. Let's say now Zara. Zara is very rich. She is generous and wants to give Mr. Tran an extra $1. Very generous. Zara's like, I'm very rich, but you know what? I'll give you an extra $1. How much money do I now have? 4. So logically, 3 plus 1. I'll take off the dollar signs to make it easier. 3 plus 1 gives me 4. How much does Nick still have? 3. Is this statement still true? No. But to make it true, what would Zara have to do? Give Nick $1 as well. So in overall, she spent $2, right? Gave out $2. But I know, so generous. But the idea is, can you see, there's a very simple concept here that whatever I do to one side, the statement will not be true unless I do to the other side as well. So then now, Nick has $4 as me. So yes, it's different. 3 equals 3, 4 equals 4, they're different numbers. But the point is, this statement is still true. Now let's take it a bit more, and this is where I was trying to show my other class that the year 12s can make a mistake here. Very simple idea. Whatever you do to one side, you do to the other. Very simple idea, right? So here, what if I split up that $4? Let's say Nick still has $4, but instead he has a $2 coin and a $2 coin. Is that still 4? Yeah. That's still 4. Let's say Zara now is even more generous. Okay? Zara's like, you know what? I gave you $1, but I felt like I wasn't generous enough, so what I'm going to do is I'm going to double Mr. Tran's money. I'll make it triple. Let's make it triple. How much money do I have now? 12. Because tripling my amount, 4 times 3, gives me $12. So whatever I do to one side, I do to the other. Now, if I times this by 3, what's 2 times 3? 6. 2 plus 6? What's the problem? Why is there that Zara did exactly the same thing for me, which tripled my money. Zara did the same thing on the other side, tripled Nick's money. Why is it that Nick and I have a different answer? See, with the numbers, it's more obvious. But when we start doing algebra, students all the way up to year 12 will make this error. Can anyone spot where the problem is? The other class figured it out after looking at it, and someone picked up a very nice sentence. They said it was a very nice way to sum it up. But what is the problem? Why does Nick not have the same amount as I do? Someone tell me. Ryan.
You didn't times both the twos.
Oh, now why? So the other student had a sentence that really encompasses why do we also have to times. I'm just going to take this a bit away. Why do we have to times not just this 2, but we also have to triple this 2? What was the reasoning? Why is that?
Because the other one's I'm just guessing. The other one's a whole number, but this one's 2 digits.
Yes. Okay, so I love how, when we were saying this, we say it so naturally that we don't even realize the things that I've been teaching in chapter 5. I talked about terms. What you're really saying is this is the total. That's what the other students said in the other class. They said, that's the total that Mr. Tran had. Mr. Tran had a total of $4. Now, if you think about Nick's total was not $2. His total was not 2. His total was actually 2 plus 2. But the interesting thing is because it's made up of 2 parts, which is what I taught you, I talked about terms. I said in an expression, a term is separated by a plus or minus sign. There are 2 components. That's why when you triple one side, the problem is that students just do, whatever you do to the left, you do to the other side. Yeah, we speak that mantra, but they don't understand the mathematics here, that it's not just triple of one component, it's the total. And you're right, there are 2 pieces. He's got 2 pieces here, so if you triple it, you do have to triple this 2, and you do have to triple this 2, because if you triple both of them, 6 plus 6 does give you 12. It does make sense. But the logic here, this exercise, when did you have to do 3 times 2 plus 2, where you have to do times 2 times 2? That was the last exercise. 5G, expanding brackets. Remember when you had to do 3x plus 2, and then you said times this, and then times that? That's where the logic's coming from. We're saying 3 groups of there's 2 parts there. So each one has to get 3 groups. Does that at least make sense? Yeah. On an intuitive sense. Yeah? So the algebra you don't really normally see, but if you take one concept, I took something very simple, and I gave you a very simple scenario, and we saw a problem. But you can imagine at a year 12 level, it's not going to be that simple. It'd be like x squared plus y plus whatever, and it gets very complicated. Yeah? So what do I want you to take out of this? 1. Write this down as part of your notes. These are the 2 things I want you to learn by the end of today. We're going to have a quiz just to see how much of it you understand, yeah? Number 1, whatever you do to one side, so whatever you do to one side, you must do to the other. Write in do. And so number 1, this is called balance equation. That's the technique. Whatever you do to one side, so I add 1, I must add 1 to the other side. The only time you got to be careful is when you times. The timesing is where a lot of students do a mistake. When you times, you got to make sure it times the total. Don't times just the individual. Every term matters. Whatever you do to one, you got to give the love to every other one. Yeah? That was the only one that you got to be careful. So that part 2, what I want you to do, be careful with multiplication. You can do a symbol or you can write multiplication. So 2 things. So the skill that I want you to focus on today is called balance the equation. We're going to solve equations just by simply doing what you just taught me here. You just said to me, whatever you do to one side, you do to the other. We do literally like that all the way through. Okay? Here we go. Here's today's simple idea. Let's say I gave you this one. Now, without this, any other problems after you copy those notes, 2 things, balance equation, be careful times. Have a look at this one. Now, this one looks scary. 2x plus 8 equals 10. Some of us already know how to do it. Some of us still learning how to do it. Now, I don't want you to think of this is confusing. I just want you to tell me, on a logical sense, 2x, what does 2x mean again?
2 times x.
Very good. This means 2 times x, so it means double something. Add 8 equals 10. Now, let's think about it just on a very purely just thinking intuition. If I blocked out the plus 8, you need to double a number. Then you've got to add 8 to get 10. Now let's think about it. What would I have to add to 8 to get to 10? 2. But I have to double a number to get to 2. So what number would that be? 1. So we know the answer is 1 intuitively. Okay, the number has to be, this number has to be a 1. Double 1 is 2. 2 plus 8 gives you 10. But what did I do to guide you? I blocked out this. I blocked out the times and I said plus 8 gives you 10. What plus 8 gives you 10? I gave you a hint, didn't I? I gave you a strategy. I gave you an order. Order matters. The order of operations that you've learned, BODMAS, allows you to do what I just did. I just gave you an intuition. So I blocked out this bit and I said, well, you have to add 8 to get 10. So what's that number? You said 2. But I said, well, that's 2 times something gives you 2. So you said 1. So intuitively, you knew x must be, write it in, equal to 1. But then I don't want you to do this intuitively because as you get through the levels, you'll find that the problems are not intuitive anymore. Most of the problems become decimals, fractions. There has to be a strategic way to get there. So I teach you strategic. What I teach you is BODMAS. Now we've seen BODMAS before. Let's see what you remember. What does B stand for again? Can I please have Fitzroy? Brackets. Very good. So I draw the brackets there just to remind you. What is O? What is O? Well, you might not know what O stands for, but what is O? Jacob, do you know? O is for order, but what does order mean?
Indices.
Indices. Very good. So it's the power. So for those who don't know, let's do a square. So that's O. O is the power. So you got brackets first, power second, and then D and M technically are the same level. What's D and M? What do you think, Hamza? Very good. Division, multiplication. Then after this order, so what comes first? It was brackets. What comes second? The powers. What comes third? Division or multiplication. And the last one, what do you think this one is, Adele? A and S. Add, subtract. Very good. So this is add, subtract. This is number 4. Now this is the order. Now if you look at the order here, we wrote before this was 2 times x plus 8. Why did I block out the 2x and I said what plus 8? Well, if you think about it, let's think about the order. BODMAS, which one comes first? Do I have brackets?
No.
No brackets. Do I have any powers? Do I have any division? No. Do I have multiplication?
Yes.
Yes, so this is the first thing I did. This is what Miss Zhu was trying to talk about, putting on an inner vest first, right? So my inner vest is number 1, which is times 2. Then plus 8. Plus 8. Now addition is the second one. So my second step, this is called a 2-step equation because I did 2 steps. I doubled a number, then I added 8, and it gives me a result. It gives me 10. So if I want to go backwards and solve the problem, just like putting on an inner vest at times 2, putting on an outer vest plus 8, then if I want to solve, I have to take everything off in the backwards order. So if I were to take it in the backwards order, I need to go 2, then 1. I need to undo, instead of add 8, I got to undo the plus 8. Now let's think about it. What's the opposite of plus 8? Minus 8. Now remember how I taught you balance the equation? I said that when you balance the equation, what you do to one, you do to the other, yeah? Here we go. Let's scroll down a bit over here. So let's look at the order. The last thing I did, so the outer jacket was 2. This is my inner jacket, number 1. So I times 2 here, and this one I added 8. The left side is apparently equal to the right side. So remember, whatever you do to one side, you must do to the other. So here we go. If I added 8 last, that was the last thing I did. I times 2, then I added 8. Then the reverse of that. Instead of add 8, you said? Minus 8. So here I go. Minus 8 on the left, but whatever you do to one side, you do to the other. So if I minus 8 on the left, I minus 8 on the right as well. Now let's work it out. What's 8 take away 8? 0. So this is gone now. 8 take away 8 is 0, right? So it's gone. 0 is gone. What's 10 take away 8? 2. So my new statement should still be the same because I'm just doing whatever's left and right? Guys, make sure to copy this down. Only same thing. Here we go. So 10 take away 8 is 2. The 8's is cancelled out. So what's left over? 2x. I still have this 2x left over. I haven't done anything to it yet. But remember, I've just undone number 2. I've just ticked this one off. I've reversed the plus 8. So it's like me taking off the outer jacket that Miss Yu was trying to say. I still have an inner jacket. The inner jacket was the doubling. What's the opposite of doubling? Yeah, you divide it. Very good. Exactly that. It's that simple idea. I'm dividing now by 2 because I times 2. But whatever you do to one side, you must do to the other. Very simple concept. But it is that order that you're doing. So let's divide 2 on both sides. What's 2 divided by 2? 1. So you can write it as 1x is equal to 2 divided by 2 again is 1. But we don't write 1x. We're too lazy. What do we write? X. So x equals 1. Now that's what we guessed before, wasn't it? We guessed it was 1. It's true. But I did it strategically. I did it at a strategic level, but how did I do it? I had to work out number 1, number 2, BODMAS. Then I had to undo it. So going backwards, you're doing number 2, then number 1. Now an acronym to help you remember the order is the backwards of BODMAS. If you read BODMAS backwards, it's actually Sam Dob. The order when you're trying to solve, you always try to get rid of addition, subtraction first, get rid of multiplication, division second, and any brackets or powers last third. So you can see how I got rid of addition first. So I got rid of the plus 8. Then I got rid of the division second because I'm going backwards. So write down SAMDOB to help you for those who don't know this technique. Write down SAMDOB to remember when I refer to SAMDOB, I mean undo the problem, go backwards. So you do addition, subtraction, get rid of that first before division, multiplication, before brackets. This here is an advance to beginner. You do this all the way up to year 12. This technique will allow you to solve a lot of problems. For those who looked at this and said, I have no idea what Mr. Tran said, then here's an entry level. But you will get capped by the time you get to 7D. Okay, when you get to 7D, you get capped. So here, this is how it works. It's called a flow chart. How do you do the flow chart? This is how you do it. Let's read it again. So remember, what was the order again? You started off with X. What did we do first? Times. So right here, times 2. That's what you did. Right? You times 2, and then what's the third step? Sorry, second step. What'd you do? Well, no. So you times 2, so X, you times it by 2, you double it, and then plus 8. So that's how you got 2x plus 8. Yeah, so double x plus 8. Now, if you're going backwards now, on this side, you know the answer is 10. You're going backwards. You undo all of this. Instead of plus 8, you? Minus 8. So you can see I'm moving down. This is number 1, number 2. Then you're going backwards now. Number 2, number 1. So minus 8. This one must be divide 2. Now, a lot of students as an entry level like this method because it's visual. 10 take away 8. What's 10 take away 8? 2. 2 divided by 2? 1. That's how you know x equals 1. Hands up if you understood the flowchart method. Hands up if out of, 10, you felt pretty comfortable with that. Good. This is an entry level. You can start there for exercise 7B. This one is what I ideally want you to get to eventually because this layout will help you solve 7D onwards, even fractional ones. This one gets a bit tricky, but it's a good way to enter into the game and get confident with algebra. Flowchart. Let's do one more example, and then I've got a quiz on the next page for you to try yourself. 4 examples. I'm going to go around and check if you've got those 4 correct. Then you have your time to do your exercise. And then lastly, Miss Yu will take over and she's got a little quiz to see how much you understand before you leave. Okay, we'll collect that sheet tomorrow. So you've got some time to do them. Yeah? Let's start off this. Can you flip over the page? Here we go. Let's do this example now. Same thing. 2 methods. Let's order. Let's figure out the order. So I've got 5x minus 2 equals 13. What does 5x mean again? Good. So it's a times 5 here. So x, I'm timesing by 5, right? Next one. I've got minus 2. Now, which one comes first according to BODMAS? Which one comes first? Times. So this one's first. Which one's second? Which one's second? Minus 2. You're picking up. Very good. So it's 1, 2. So if you want to do the flowchart method, x, what did I do to x first? I times 5. So you write it in. You say times 5. After you times 5, that was number 1. What's number 2 again? Minus 2. That's how you got 5x because you times by 5 and then you take away 2. Now the answer is 13. So if you want to go backwards, undo everything. Opposite of minus 2? Plus 2. So I'm going backwards now. So I'm undoing the second one. Plus 2. Once I undo that, so 13 plus 2 is 15. But then opposite of times 5? Divide 5. I'm loving it. You guys are starting to pick up on this idea. Make sure to copy this down, Zara. Number 2, number 1. Here we go. Let's work it out. 13 plus 2, 15. Divide by 5? 3. Look at that. This is flowchart. Good entry level. Eventually, I want you to do this one. Okay? Copy this down. Make sure to copy it down. Here we go. Sarah, at least copy this second example, yeah? So over here, 5x minus 2 equals 13. If you're doing the balance equation, if you want to have a go with this one, this is what I ideally want you to practice over here. Order again. Order was times 5, that's number 1. Minus 2 is number 2. So if you undo, remember Sam Dob? Which one do I get rid of first? Very good. I need to get rid of that 2 because it's a minus. Yeah, Sam Dob? Which one do you get rid of first? You are going to get rid of any subtraction addition first. That's number 1. So how do you, yes, very good. Yeah, we're picking up. There we go. So minus 2, add 2. But whatever you do to one side, you must do to the other. So negative 2 plus 2 or 2 positive 2 minus 2 is 0. Gives you the next line. I still have the 5x on the left-hand side left over because these two cancel out. 13 plus 2, we know that's 15. We're almost there. We're trying to find x. But I don't want times 5. This is a times 5 there. So the next step is get rid of the first step. Opposite of times 5?
Divide by 5.
So whatever you do to one side, so I divide 5 here, I must
Divide 5 there.
divide 5 there. So 5 divided by 5 is 1. That's how you get 1x is equal to 15 divided by 5. You get 3. But we're too lazy as mathematicians. We don't write 1x equals 3. We write? Beautiful. Was that easy? Out of 10, can I get a show of hands if you felt about 7 out of 10, at least? Yeah, okay, good. What about 6 out of 10? All right, good. So most of you got a general idea. This is 7B. At the bare minimum, what I'm asking, no matter which method you use, method 1 or method 2, I want you to find one that you're comfortable with. Ideally, it's this one. Question, method, answer, vertical layout. That's what I'm looking for. So far, so good? Yes? All right. You got 7 minutes. I'm going to walk around. Once you finish it, can you show me so that I can tick it off? I'm going to stamp it, and then you can then work on your exercise. But I want these 4 problems done either method 1 or method 2. I don't care which one, but you have to solve it. I need to see it working out to get an answer. Okay, 7 minutes. It's currently 2:26. I want to see the method. Once you finish, put up your hand. I'll walk around and I'll stamp it. Okay? Here we go. I'm going to stop the video. That's it for today's lesson. That's what I want to see that I